Hello, today we're going to wrap up Unit 5 by talking about catalysts. So there's a few things that you need to know about catalysts. Catalysts speed up a reaction, so they increase the rate of a reaction, but they're not used up. So they're, by the end of the reaction, they're the same as they were at the beginning. And then because they're the same, they're not in the overall balanced equation. Sometimes catalysts in the balanced equation, sometimes we'll write the catalyst over the arrow to show that it's there. So maybe it's oxygen or maybe it's a platinum catalyst. But typically in the overall, it will not be considered a reactant or product. In the mechanism, it could be a reactant and then a product later on, but it is not in the overall balanced equation. Now, catalysts could work in two different ways. It could be, it could function to increase the number of collisions, or the frequency of collisions rather. And the other way it could do it is by changing the mechanism. But either way, it will increase the rate and they're not used up. So these diagrams show catalysts that work by changing the mechanism. Here is an example of an energy profile diagram. Now, one of the things that we've talked about before is that the energy profile diagram for a catalyzed reaction will typically have just a lower activation energy, like this. The reactants and products will still be at the same energy. Another way that it could do that is by changing the mechanism so that there's might be more than one step. So in this diagram, you can see that it moves it to two steps, where each of them have a lower activation energy, which speeds up the reaction. So that would be an example of it changing the mechanism. You can change the mechanism and still have just one step and have a lower activation energy. That's fine too. Either way, when you have a lower activation energy on your Maxwell-Boltzmann distribution curve, you're not changing the curve, you're just lowering the energy, so you'll have more particles being able to react because they have enough of that energy. Another type of catalyst is a heterogeneous catalyst. Heterogeneous means that they're not the same state typically. So you might have a solid catalyst and an aqueous or a gaseous reactant. And so this part here is the catalyst. Okay, this is how catalytic converters work in your car. But they basically provide a surface to which one of the reactants can bind to that surface, and it holds it in place so that the other reactant is more likely to collide and react. And then once it reacts, then it's able to leave. So again, the solid catalyst can work by holding the reactants in place so that they can react. They can collide easier and react more frequently. Now, enzymes are proteins that also act as catalysts. Enzymes work in a specific way. They're very similar actually to heterogeneous catalysts. They work by holding the reactants together. And in biology, they call those reactants substrates, and they bind to the active site. Whereas in heterogeneous catalysts, they just bind to the surface. All right. Now, enzymes, because it's holding it together, it will make it easier for it to react in the correct orientation because it's holding it with a specific shape in the active site. And so it can react in the particular way that the enzyme is trying to get it to react. And once it does that reaction, then the enzyme will release the product. There are a lot of things that affect how an enzyme will work, such as temperature and pH, and anything that makes the enzyme, the protein change shape will affect the effectiveness of the enzyme as a catalyst. But for AP chemistry, you really should just know that enzymes are a type of catalyst. They speed up a reaction by making it easier for the reactants to collide.